Dear students, we will learn the one problem of condenser, and the problem is the temperature of a surface condenser is 42 degrees C, and the vacuum inside the condenser is 685 mm of mercury, where the barometer reading is 749 mm. So this vacuum is to be corrected with respect to the standard barometer of 760 mm. This is the one part of the problem. Second part is determine the pressure of the air and steam inside the condenser and the mass of the air which is associated with 1 kg of steam. Here the characteristic gas constant is to be given 0.287 kJ per kg Kelvin. So such type of problem is to be solved. So we look the diagram, one diagram. Here this is the condenser, and this one is the condenser which vacuum is to be given. This is the 685 mm. This vacuum is to be obtained when the barometer, here this is the barometer, when the barometer reading is 749 mm. So we have to find the absolute pressure of this condenser. So here the barometric height is to be given. This is the 749 mm of mercury column, and here the vacuum is given. This vacuum is 685. So the absolute pressure, the absolute pressure is the difference between these two pressure, which is equal to 64. Which is 64. Difference between this 749 and 685. So this is 64. The absolute pressure is 64. Is equal to 64 mm of mercury column. Now this is 64. Now if the barometric height will change, or when it will become the 760, then the vacuum inside the condenser will be different. So the vacuum, now the corrected vacuum is equal to 760 minus the absolute pressure of the vacuum. So this comes out to be 696 mm of mercury column. This is the one part of the problem. So this was the corrected vacuum with respect to the 760 mm of mercury column. Now the second part is to find out the pressure of the steam. So it is the pressure of the steam and air, because this condenser consists the steam as well as some part of the air, as the problem says. Now this pressure, this 64 pressure, absolute pressure, is which is in terms of mm of mercury column, is to be converted in bar. So one things which has to be noted, that the 760 mm of mercury column is equal to 1.0132 bar. So the 1 bar, 1 mm of Hg is equal to this. So this can be find out by dividing this 0.011325 divided by 760. So this comes out to be 0.00133 bar. So this is the 1 mm of mercury is to be represented in terms of the bar is this. Now the 64 mm of mercury of the condenser is equal to 0.01 0 0 1 3 3 3 multiplied 64, that comes out to be 0.0.08512 bar. So this is the pressure of the condenser in terms of bar. So this is the total pressure in the condenser. This pressure contributes the air pressure. This is the air pressure and the steam pressure. This will consider the air pressure as well as the steam pressure. This one, the air pressure plus of steam pressure, because this is the total pressure and steam pressure. Now we will find the pressure at the condenser temperature from steam table. So the pressure at the rate of 42 degree from the steam table, that comes out to be at 0.08082 bar. This will comes out to be. So we will subtract this pressure in total pressure. So that will be the this is the steam pressure at 42 degree. So we will subtract the steam pressure in total pressure, we will find the air pressure. So this air pressure is equal to 0.08512 minus 0.08208. So this pressure is equal to 0.00304. So this one is the air pressure. Now at that particular pressure, so this is the part 2 where the air pressure and steam pressure is to be known. Now the mass of air associated with the kg of steam, 1 kg of steam. So we will find now at 42 degrees C, from the steam table, the volume of steam is to be given. Here the volume of steam at 42 degree is to be given. That comes out to be, this volume is 17.61 meter cube. This volume is also the volume of air. So we have the volume of air and pressure of air, temperature of air, and the R is to be given for the air. So the mass of the air is equal to PV is equal to MRT PV divided by RT. We put the pressure and volume here. So here the pressure of air is 0.00304 multiplied 10 to the 5 multiplied volume is 17.61. The pressure of the air is equal to pressure of air is equal to 0.00304 bar, and volume of the air which is equal to volume of the steam at 40 degrees C, 40 degrees C from the steam table, that comes out to be 17.61, because the container are same, so the volume of steam must be equal to the volume of the air. So the mass of the air which is present inside this condenser is equal to pressure of the air, volume of the air divided by characteristic gas constant of air multiplied temperature in Kelvin, which is 42 degrees C. So we will put the value of here, the pressure 0.00304 multiplied 10 to 5 multiplied volume 17.61 divided by R 287 multiplied 42 plus 273, that comes out to be 0.0